Welcome to the course of Multimodal. In this course, we will be diving deep into concepts of foundational models, their applications, and related technologies. So, coming to the first point, what are foundational models? Foundational models are machine learning or deep learning models that are trained on broad, diverse data sets, typically using self supervised at large scale. So examples are one of the most common platform that we use is ChatGPT. These models are designed to be flexible and adaptable to allow them to applied across all the downstream tasks. Like even if we have tried ChatGPT, we can try in various diverse tasks like summarizing, categorizing, or even writing code. So coming to the foundational models are divided into mainly three parts. Large language models, which are also called LLMs. These are models which are powerful in natural language processing, but they are too specific when focusing solely on language. Then second is self-supervised models. These are models that are trained without explicit human labor. So, if you take an example, when we have to just label all the photographs in an iPhone, we just label one photo, and the algorithm automatically uses self-supervised learning and suggests that these people are labeled by this human being. Then comes pre-trained models. Pre-trained models are the large data sets before just which are being performed before fine-tuning. However, focusing on pre-trained might be too narrow for understanding the full potential of foundation models. These are like weights which can be used to perform various downstream tasks. Coming to foundational models are studied in two parts. One is language models, which are LLMs, and then are vision models like diffusions, and then the mixture of both LLMs and vision are multimodals. So these are task specific models. They can be made on top of pre-trained models like BERT, GPT, or even CLIP and DALI. Then these models are used to make it into a downstream task so that they can perform on a particular task. A good example is GPT-3 and Palm by Google, which have algorithms on top of pre-trained models like chain of thoughts and context learning so that they can perform well on a particular task. Then coming to the world that we are living in, currently there is a lot of hype of AGI. So these are general purpose assistants that are made on top of these pre-trained models so that they can perform all type of tasks. So coming to the multimodal are various type of data such as text, images, videos, and 3D models, so that they can have multiple modalities and they can provide understanding of the entire world, and they can actually interpret anything in any format. So it consists of text, images, and videos, then 3D rendering of different animations, audios, and even touch. So if we get a model where we can have an integration of all these different type of modalities, we can get multimodal. A good example of this is Sora by OpenAI. Then we have multimodal models which are for 3D rendering. We can just write the prompt and we will get the entire 3D perspective of an image. We also have Dreamcraft 3D, which is one of the state of art algorithm to get 3D animations. Then we have Blip 2, where we can get the modalities between image and text, and we can have all the conversation based on a particular image. We can even just analyze image and ask the large language model so that it can interpret for us and explain what is happening in the image. Then we have audio integration with LLMs, like a very famous ChatGPT O1 had this feature where the person can speak in real time and they can analyze the environment.
Hey, how's it going?
So you can see
Hey,
a demo
Rocky.
here.
I'm doing great. How about you?
I'm awesome. Listen, I got some huge news.
Oh, do tell. I'm all ears.
Well, in a few minutes, I'm going to be interviewing at OpenAI. Have you heard of them?
OpenAI? Huh? Sounds vaguely familiar. kidding, of course. That's incredible, Rod.
So the use of these multimodals are very much used in this current environment. We can analyze almost anything in real time. Another good example is Project Astra by Google. So we have seen this trend that earlier we used to capture visual moments in 17,000 era to up to 2020, but now what the change is having in our trend is we are now letting the machines understand our 3D world. So from helping everyone capture visual moments, we are shifting to teaching machines to how we see the world and how they can analyze the world. So teaching machines to see the world is very common in 2024. Now many people might argue that it's altogether a very dangerous thing that is happening. Now we see Tesla's robot which are capable of doing almost anything that a human can do, but it is also on the other hand helping us to do in various fields like virtual reality, autonomous vehicles which can drive automatically by themselves, and 3D reconstruction. Now we just need an image and it can automatically capture everything in 3D. Coming to what we will be learning in this course will teach us how machines see and interpret the 3D world, which has applications in all the domains like augmented reality, autonomous systems and all. So there are two aspects of learning. One is to learn from image into a 3D representation, and the other is vice versa, where we are learning the image from a 3D representations. So both have their own challenges, and coming to the problems, the foundational models were developed where was the integration of learning through their own, so that they can have a interpretability between image and their 3D representations. So many of the recent development in this field was when we saw one of the recent paper, 3D photography in CVPR 2020, which introduces a method for turning single 2D images into interactive 3D photographs with realistic motion parallax. Then there was introduction of consistent video depth, which proposes a technique for generating temporarily consistent depth maps across frames, videos, sequences to ensure smooth transitions of the videos. A good example of this was robust CVD. We can see how a frame is analyzed and the human being is being detected in a video. Then there was introduction of dynamic nerve. It was an ICC paper in 2021. It extends the neural radiance fields to handle dynamic scenes, enabling rendering of realistic time-varying 3D environments from the video data. Then there was also robust dynamic nerve. These are one of the most recent research papers that developed the video generation from text. Then there was Hyperreal, a system of high quality real time 3D video reconstruction and rendering that enables immersive experience in dynamic settings. We can see a person has just captured a photo, and just by moving a mouse we can reconstruct the entire video. So these were the recent trends that we saw up to 2024, but in 2024 everything is changing. A lot of foundational models are developed. All the top companies are just recklessly focusing on building their own models. We see CVPR 2024, Seeing the World Through Your Eyes. It explores gaze-driven video processing to enhance scene understanding by aligning video content with the viewers of a eye movement. So how a person moves his eyes and understand the 3D world is analyzed by this paper. Then a similar paper is PBIR. It proposes a neural approach to physics-based image, so that things like game development and foundational model can work into that field, so that it improves the fidelity of the light and material interaction in synthesis image generation. So reconstruction have been very common in 2023 and 2024, so that a image can be generated and constructed with just prompts and 3D views. Then we also see Climate Nerve. It applies NERF models to climate data visualization, enabling us detailed 3D representations of environment that changes over time. These are another example of this model. Then we have 3D motion magnification. It allows a single image to be converted and magnified to its depth. We can understand the 3D world through magnification. This was proposed in ICCV in 2023 by Stanford. Then we have distortion correction. This is also used in recent models to generate videos and understand the 3D interpretation of the world. This was a fun with graphics paper. We can see that it has reconstructed the entire 3D model and we can analyze it from different angles. So these are the recent trends that we see. Now each and every foundational model is made with some fundamentals. So there is the requirement of understanding the core architecture, and we have to understand how the backbone of foundational models are developed. So we will be dividing the entire course into 3 different parts. The number 1 being neural architectures for foundation models. Here we will be learning all the fundamental backbone of the development of foundational models. Then large language models. We will be analyzing different large language models that exist in 2024 and the techniques that we should apply so that we can fine tune and get specific tasks done by these large language models. Then we'll be diving into large multimodals. This will be including both large language model and vision models. So as we just saw some of the papers where we were analyzing both image and text, so it would be covered in large multimodals. Coming to the topics that we will be covering in neural architecture for foundational models, we will see transformers. This was a 2017 paper by Google which had the entire development of foundational models. Each and every model that we see is made on top of transformer architecture. It's a revolutionary neural network architecture which pivotal for both large language models and multimodals. It relies on a concept called self-attention that we'll be seeing in the later lectures. It is used to handle sequences of data, eliminating all the problems that we used to have in conventional neural networks like CNNs and RNNs. It works on attention modules. This allows the model to focus on relevant part. Like if we write a prompt of 20 words, the attention mechanism helps to think like a human so that the large language model can just get the 21st word. So this was extended to even vision models, making the 3D rendering that we see in these papers. Then after attention we will see position encoding, how each and every word is traced so that it follows a particular sequence, and there's the input and maintenance of the notion for sequence and structure is being preserved. Then we will be seeing efficient attention. It is also a state-of-art technique which was developed after transformers. It is very powerful for attention. It can become computationally expensive, especially with large data sets. Thus, this efficient attention was proposed. After that, we will also see flash attention. It is a more optimized and faster version of attention computation that reduces memory usage and improves processing speed, so that we will not be consuming too much GPU that a conventional vanilla transformer was using. Then we will also see different newer architectures which have been proposed up to this 2024. As this field is very growing and very rapid, all the top companies are just into it and introducing one after the other algorithm every day. So enhancing of performance with the capability of foundational models across different modalities was a very hot topic that was to be studied. After understanding neural architecture of the foundational model, we will be jumping on to the most heard topic, which is large language models. Large language models, also called as LLMs, represent one of the most prominent advancements in artificial intelligence. These models are trained on vast amount of text data, which have the capability to understand like a human language and how a human being thinks. It can use to generate text and manipulate human language. The key features that we'll be learning in upcoming lectures is training of the entire LLM, typically involving pre-trained phase using self-supervised learning, where the model learns about the unlabeled text data. This will be followed by a supervised learning fine-tuning method, which will be taken care of using attention module. Then we will be learning about pre-training and instruction fine-tuning, This includes the fine-tune methods so that the data is analyzed by attention modules, and it can tailor into particular tasks like answering question or maybe fill in the blanks or any way that we want to use the LLM. Then we will be learning about alignment methods. This is achieved and these methods were uh, like brought because there was a goal to align the model's response to be more human-like, so that it answers and thinks the way human thinks. So there were methods like reinforcement learning from human feedback, which is also called RLHF, and distributional policy optimization, which is also called as TPO. So we'll be learning and coding these methods from scratch. Then we will be learning about prompting and in-context learning. Now, when LLM was brought into world in 2022, mainly by ChatGPT, LLMs could understand context within a single input, meaning you can prompt the model by giving it instructions or examples. So this method was studied and it was fine-tuned using this prompting method, which was also called as in-context learning. So we'll be learning some tips on how to prompt and how a LLM thinks, and we can fine tune on downstream tasks. Then we will be learning about tool augmentation. Now LLMs are also augmented with external tools such that it can search onto the web and retrieve data from all through different information specific tasks, like we see in Perplexity, which where it enhances and get searches results from Google and then analyzes and give the result. So we can do this using one of the top method in LLMs called RAG, retrieval augmented generation, where we will be using different sources to get data on top of large language models so that we can get a non-hallucinated version of the answer that we want. Then we will be learning about parameter efficient tuning. So this was proposed because there was a shortage of GPU. A normal human could not use their large language model onto their computer. So there were various methods like low rank optimization, also called as LoRa, which was discovered in 2022 and 2023. So these methods allowed us to easily use these large language models onto a low computational devices. Then we will be learning about efficiency. Key concerns in LLMs are optimizing efficiency and optimizing it such that everyone can be using these methods into a low parameterized version. So there were various methods that was introduced like optimization, speculative decoding, then quantization, which is one of the most famous in LLM, where we are just we are just converting 32-bit into 4-bit so that it can be more efficient and it can be compressed into a smaller version so that we can use less GPU. Then we will be learning about agenting AI. LLMs are increasing their design and it is being autonomously being developed so that they can have two LLMs that can talk and to each other so that there is no hallucination and they come to a proper conclusion to a point where human being understand and agrees to the question that he has asked. So this was discovered and studied in agent AI, which is very common and famous in OpenAI. Even the most recent algorithm ChatGPT o1, which solves all the problem, uses agenting AI in the backend so that it can analyze and come to the proper conclusion by just letting the LLM understand the way human thinks. After large language model, we'll be learning large multimodals that we discussed. We'll be analyzing different types of data sets into a single multimodal of all the four categories of data: image, videos, text, 3D models, and even touch. So we'll be starting with a vision transformer, which was state of art, like LLMs that we saw. It is also made up on transformer. It handles vision data using attention mechanism. This model process image patches similar to how transformers handles individual tokens in LLMs. Then we'll be learning about self-supervised learning. Similar to LLMs, multimodals are trained using vast amount of unlabeled data, which is done by self-supervised learning model. Then we will be learning about multimodal pre-training, how models like CLIP are trained on paired text and images so that it can understand the connection between a particular image and the token that we want to analyze. So it gives a broad interrelation of how a language and vision are combined into a framework. Then after that, we will be learning large multimodals, which are being proposed recently. And then we will be learning about grounding. One challenge of multimodal is grounding, which is referred to how well the model can be associate a particular language. So for example, recognizing the phrase dog in a park and accurately identifying it into the image was a problem. So this problem of grounding was solved, and we'll be seeing how to solve this problem and get the right relationship between a text and an image. And similar to large language model, we'll be learning about efficiency, because multimodals have faced their own efficiency challenges due to high dimensional nature of input text and images. And we will be requiring architecture. We will be studying about architectures and training techniques to see how a large scale multimodal data can be prepared. After that, we will be studying the evaluation of multimodals and how to exactly assess the performance of a multimodal so that everything is being taken care, including text, 3D, audio, and even the images. Then we'll be studying about generational strategies, which is beyond just analyzing multimodal data. These models can generate outputs, creating realistic images, videos from textual descriptions. So we'll be learning about this in the upcoming lectures. Beyond vision and language, we will also see image, video, and 3D generations that we saw in some of the recent papers in this lecture. So come and dive deep into the foundational models. This world of generative AI is completely different, and we'll be seeing all the latest trends that is happening in top tech giants and in top conferences which is happening of artificial intelligence. So these are some resources that you can follow. That's it. Thank you.